Alright, so we need to calculate the OH minus ion concentration and the pH at equivalence point. And what we are titrating? Propionic acid, 500 milliliter, 0.1 molar with calcium hydroxide, and Ka value is given. So first step, we need to find out the moles of propionic acid. That's first step we need to find. So first, moles of propionic acid. We can calculate 0.1 molar is given and 500 milliliter we convert into liter and you get 0.05 moles of, we can say HPR, that's the propionic acid, HPR, propionic acid. Alright, now when you write equation, I'm going to write HPR, propionic acid, and calcium hydroxide, CaOH2. Then we write Ca, now we need to balance it, so CaPr2, and let me write down, okay, and then 2H2O. So when you do that, you see there is 2 to 1 ratio, 2 propionic acid to 1 ratio. So for that we need to find out moles of calcium hydroxide, CaOH2. How do we do that? We know that 0.05 mole HPR, propionic acid. Now we know that every 2 mole HPR used and it reacts with 1 mole of calcium hydroxide. So using this stoichiometric coefficient we can find 0.025 mole of calcium hydroxide, CaOH2. So that's first step, and second step we found moles of HPR and moles of CaOH2. Now we need to find volume. Okay, so we are going to find volume of CaOH2. Alright, so let's see. Volume of CaOH2. We know that 0.025 mole of CaOH2. And what's the concentration we have? 0.05 mole per liter. So we can say 0.5 liter of CaOH2. So what will be the new volume? New volume will be 500 times 10 to minus 3 liter. That's the initial plus 0.5 liter. We are adding that here into the original. So you get about 1 liter. Right? Because we are adding acid and base together. So that's why new volume is 1 liter. Now what will be the concentration of PR minus 1? It's 2 times 0.025 molar. So we have 0.05 molar concentration. Right? Well, how do we get that? What is the concentration of PR minus 1? How do we get that? 0.05 mole divide by 1 liter, so you get 0.05 molarity. So it's a PR minus 1 concentration. Now, we can calculate Kb equals Kw divided by Ka. We have Ka given and we know Kw. So we can plug that number and find out Kb, which is 7.7 times 10 to minus 10. Now we have everything. Now we'll plot I start. Right? We have the concentration PR minus 1. That's the concentration we have. And we have Kb. So we can use I start. Okay? So let's see. For the next slide, we have PR minus 1 and H2O, HPR and OH minus 1. So when you develop I start, initial concentration of PR minus 1 is 0.05 and HPR is 0 and 0. Change minus X plus X plus X. Now 0.05 minus X plus X and plus X. So that is at equilibrium. Now we are going to write Ka expression. For this one, it is HPR, OH minus concentration and PR minus concentration. When we plug that value, you have Ka, which is 7.7 times 10 to negative 10 x square and 0.05 minus x. Now, we assume that, now in here, 0.05 divided by 7.7, 10 to minus 10, which is greater than 1000, right? So we can assume 0.05 minus x equals 0.05. So that makes our calculation easy. So for that we will discard that. When you discard, you get x square and these two you are multiplying. So you get 3.85 times 10 to minus 11. When you take square root, x equals 6.20 times 10 to minus 6 molar. That's the concentration of OH minus 1. That's the concentration of OH minus 1. Now we can find out POH and pH. Now we have OH minus concentration. We can find out POH and pH. So if we have OH minus concentration, the POH, which is 5.21, and pH, using the equation, you can solve it 8.79. So that's how you calculate concentration and then after pH and pOH of this acid-base titration.